Hello students, Miss Walsh here. So I hope you were able to understand the video that you watched by Khan. Just a quick little recap. Remember, the goal was to actually take a look at how many cases there are, not how many are declared officially on a day. Okay, so what did we need? We needed a mortality rate, and he took 1%. Some predicted slower, some predicted higher. 1% is widely held. And then he had this time from infection to death. Basically, the number of days from the moment that you contracted the disease until you pass away. That was made up of a 5-day incubation rate, because incubation time, because it takes about 5 days for the symptoms to start showing, and then another 15 days from the moment that you start showing symptoms to when you finally pass away. Okay, and then he had this number, and this is a very important number I've mentioned in the past podcast, and that is in how many days is your number of cases doubling. Okay, so he had the doubling of 5 here. Okay, so what that meant is from the moment that the person catches the disease to when they pass away, 20 days pass. So this is a working backwards model, actually. So he took a death that happened today and he looked at, well, what happened 20 days ago? Okay, well, so this person passed away. So 20 days ago, since you have 1% of the people dying, you must have had about 100 people contracting the disease. After that, you had a doubling every 5 days, and so you go from 100 to 200 to 408 and 1600 finally. And so that is kind of your actual number of cases. Well, let's see what happens when we try to apply this to real data, okay? And we're just going to look at Italy. And we're going to take a look at Italy on April 12th, okay? So here we are, and it's April 12th. Okay, we're going to stick with a mortality rate of 1%. And the doubling time, I'm going to go to my spreadsheet here. And what I have is I have Italy right in this column, okay? And if I look, well, on the 12th of April, we had 156 cases, and so I just backed up. So this is roughly 150 or 160, and I just roughly backed up to when it was half of that, and I backed up to this number actually. And so we had 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. And the reason that I took this number and not this one is because I wanted to deal with 18 rather than 17. Okay, so 18 days to double is actually quite kind. It's a long time, and the reason for that is because the situation in Italy is improving indeed, okay? If we looked at something earlier, so for example, if we looked at March 19th, and we were at about 40,000 here, if you look at how long it took to double then, look, you're at 1, 2, 3, 4, 5, a number that Khan used. Okay, so we're going to stay on the gentler side and take this 18 as our doubling time. Okay, so here we are. So we know that our doubling time is 18 days, and we're going to stay with the incubation of 5 days because this is also widely used. It takes several days for you to start showing symptoms, and this is what makes this disease so dangerous, is because you're highly contagious even when you're not showing symptoms. And finally, the symptoms to death, what I did is I took it to be 13 days. Perhaps it's a little bit more. Remember that Khan's was a little bit more. His was 15, and the reason that I did that, maybe you notice, is because I wanted the number to be nice for our purposes, okay? If I took more, then I'm at 19. I'm gonna have to go into fractions, and I didn't want to confuse you with the fractions. Okay, so what does this mean? We have so that means that we have 18 days from the moment that the person caught the disease. Okay, so this is to the person, to the moment that people passed away here. Okay, so this is going to be our 18 days ago. And so what we need now is we need the number of deaths. Okay, and oh my goodness, I've got my data right here. Okay, so we had deaths in Italy on April 12th. We had 431. Okay, so we had 431 people die in Italy on April 12th. You've got a mortality rate of 1%. So 1% of the people that contracted it 18 days ago passed away. So in order for us to get the full 100%, we are going to have 43100 cases on that day. Okay, now this is 18 days. And so what that means that in this period, I'm going to be able to fit exactly one doubling amount. And this is maybe, now it makes a little bit more sense why I took this to be 13 and not 17, because then I would have had, or 18, would have had 23 here, and then it's like 1 point something doubling, whatever. Okay, so if we double this, what this would mean is we get 86,200 new cases. It's an exclamation point there. Okay, so this is not total cases. This is new cases. Would be good to know how many new cases were there actually. Oh my goodness, I've got the data right here. So we're going to move the deaths out and we are going to take a look. Okay, and there were actually 4,000. Okay, there were 4,000 deaths, and what we ended up, so what was it? It was 4092. Official new cases. Okay, so look at this discrepancy. It's absolutely huge. And not only is it huge, but this is done with a very kind doubling period. It's done with a doubling period of 18 days. Okay, now when things were happening in Italy that were going pretty bad, the doubling time was a little bit was much less. Just to show you, this model is not really realistic. You couldn't really see it from the video, but there's a number of issues with this model. Yes, certainly one of the problems is the mortality rate, right? In Italy, the mortality rate is actually a lot higher, and the reason for that is because they were not testing nearly as much as in Germany, so the number of people that they had showing to be positive, out of that, it looked like they had a lot of deaths. That's one of the days. But there's other issues with this. So let's just see, just to show you why this model doesn't really work, is let's just take the doubling times to be 6 days. Again, I took 6 and not 5 or 7 so that it fits nicely. What this means is that I would fit 3 doublings in 18 days. Okay, and I'm just going to change color here for dramatic effect. Because remember, this is a total period of 18 days. And let's double. Oh, okay, I already know my first doubling, duh. 86,200. Now we're going to double it again. And then we're going to double it again. And what you get is you would get 344,800 new cases. Okay, so that would mean that 2 days ago, when things in Italy are already improving, we would be having not that far off from 500,000 people declaring to be positive on just that one day. Okay, so one of the reasons that this is not going to work is this is a dynamic model. Okay, the dynamic model is one where things are changing. This doubling period is not constant. The doubling time is changing all the time, right? If it was constant, then what would happen is these numbers would be doubling, like 2, 4, 6, 8, 16. It would be doing so at the same increments, and it's not. Okay, so this is a dynamic model where things are changing, and dynamic situation. And we're using a static model. Static means that things are not changing. We're keeping the mortality rate the same. We're keeping the doubling rate the same. Okay, the incubation period is what it is for the disease. That's fine, but this is going to, if you kept this going, okay, so just to show you the inaccuracy of this, if you keep doubling this, okay, so take your calculator out and double this again. So that would mean that what are we at? If we're doing this with the 6 days, that means that 6 days later, by April 18th, you would have this number. And if you double it again, then you would have this number, okay? So this is 12 days later if I'm using the 6 day, or it's a month later. So that means that basically, even if we were using the 18-day period, okay, you've got another 18 days, so 36 and 36. So in another month, you have on that day over 1 million people in Italy declaring to be ill, okay? So it's good to have models. It's good for us to understand this method of using the deaths to take a look. And it's good for you to understand that the official numbers that are published are not exactly correct for a number of reasons, but this method is extremely limited, and you're going to see that in your own attempt in today's assignment. Hope it made sense. Bye.